How you going, guys? Michael here with you once again, and welcome to episode 3 of the Java VTM. If you remember, in the last video we looked at the primitive data types that are available to us in Java. In this video we're going to look at the arithmetic operators that we can use to perform different operations to these variables. Okay, so we've got a new file open. Our language is set to Java, and we'll have a bit of a comment. Arithmetic.java. This program demonstrates the arithmetic operators available. Oh, I can type in Java. Okay, that's what we're doing in this video. So, once again, we have a class, public class, and we'll call this arithmetic. Opening, curly, closing. Okay, and again, we'll have a main method, so public static void main string array args, and we'll close that off. And now I know some of you guys are really dying to know what some of the things I've been just glossing over are all about, such as the string array args. We are going to get to that, I promise. It's just that we need to get this basic concepts out of the way first, so it makes a lot more sense when we get to this. So let's get started. We're talking about arithmetic operators in this video. Things like, if you remember in primary school maths, things like addition, multiplication, division, these are arithmetic operators. So to demonstrate these, we're going to start off with two variables, and we're going to use ints simply because they're easy. So remember from the last video, an integer data type was using the int keyword, and we'll call this one number A. And we'll give this a value straight away, and we'll give it the value of, I don't know, 10. And int number B, and we'll give this 7. That'll work very nicely. So, the first operator we're going to look at is probably the most obvious, I'm sure, to a lot of you, the addition operator. And in Java, we do additions with the plus sign. The plus sign is the addition operator. So, what are we going to do? We'll have another variable here, int sum. And we're going to set sum to the sum, believe it or not, of number A and number B. So to do this, we need to add number A and B together. And to do that in Java, very simply, just as we would write it out by hand if we were doing any maths at school, number A plus number B, semicolon. It's really that simple. What this does is it first takes the value of number A and adds that to the value of number B, so we've got 17 here, and then it assigns the value 17 to this new variable sum. That's what's happening on this line of code. And we can prove that by a print line statement, system.out.print line, the sum is plus sum. Now you notice here that I'm using the plus sign again. In this context, it's not the same operator as this. Here it's purely the addition operator. In here, because we've got a string here, we're doing a string concatenation, and that's what that operator is in this case. What it's doing is taking the string the sum is, and it's concatenating the value of sum onto the end of it. So if we just save this, and we'll save it as arithmetic.java, and we'll come over to our command prompt and we'll compile that, javac arithmetic.java. Wait a second, it compiles without any trouble, so we'll run that straight away. The sum is 17. So you can see what the string concatenation does compared to the addition. So, that's addition taken care of. It really, really, really is that simple. And most of the operators in Java work in a similar way, so we'll go straight on to the next one. We've done addition, so let's do subtraction. And believe it or not, the subtraction operator in Java is the minus sign. Okay, so we'll have another variable, an int variable here, int, and we'll call this one difference equals number A minus number B. Semicolon, and we'll print this out straight away. I'll just copy this because I'm lazy. The difference is the difference variable. Okay, we'll compile this straight away, save that, and we'll compile it again. Run it. As you can see, the difference is 3. number A, which is 10, minus number B, which is 7. So 10 minus 7 is 3. Hooray, hooray, that's it. Very simple. What if we did it the other way around, though? So we have difference equals number B minus number A, semicolon. We'll save that, and we'll compile that, and we'll run that. The difference is minus 3. So I just wanted to point out that it deals with negative numbers without any dramas. So either way works fine in Java. Now we're firing along through these because it is kind of basic for the most part, basic arithmetic. So the next one, we've done addition, we've done subtraction. Let's try multiplication. Okay, multiplication. And that's done with the asterisk symbol. Okay, so exactly the same as we've done with this addition and subtraction. We'll have int, and we'll call this one product equals number A multiplied by number B. And we'll print this out as well. The product is product. Okay, so what do you think is going to happen here? Well, the same as the other two examples. It's going to take number A, multiply it by number B. So we've got 10 times 70. Then it's going to assign the result of that. So 10 times 7 is 70. And it will store that value 70 back into the product variable. So we'll save that, and we'll come back and compile that. Oh, and I'll just resize this. I forgot to do it before. Java arithmetic. The product is 70. So that's working very swimmingly. Is there any problems with that? I don't think there should be too much drama. Unless you've forgotten your times tables. But really, it's not going to make a mistake like this. So, we've done multiplication. Let's go to the next obvious one, and that is division. Now, I want to talk a little bit more about division compared to the last three, because it's a little bit weird to how it does it. It's the operator for division is the /, okay? And we use it exactly the same way, except the results can be different depending on whether we're using integer data types or floating point numbers. And I'll show you what I mean straight away. Int, and we'll call this one quotient, equals number A divided by number B, semicolon. We'll print this out. We'll save it, and we'll compile it. I'll just clear the screen to make it a little bit easier to see. The quotient is 1. Now, why is it 1? 10 times 7, if we bring up a calculator, 10 divided by 7 is 1.4287, etc. So, why did it only give us 1? The reason is because we're dealing with ints. Now, you remember from the last video, integer data types do not store a decimal point. So basically, when we do the division here, the decimal point just gets chopped off. So we're just left with 1. And I can show this real quick if we do the same thing but with a few float variables. So we have float. Actually, we can just do it with 1. Yeah, float. We'll use a double just to get the better precision. Double. Equals number A divided by number B, and we'll print this out as well. Alright, so we'll save that and we'll compile that. Oh, where are we? And you see the double quotient is 1.0. Now that didn't do exactly what we wanted either. The reason is because number A and number B are ints to begin with. So that and when we do this, the result that gets put back is an int. So if we, I'm going to introduce you to a new thing. I wasn't going to do it straight away. It's called typecasting, and what it means is we take a data type that is one type, for example an integer, and we cast it into another data type. So we can turn this number A, which is an int, the value of number A we can turn that into a double. And how we do that is by using parentheses and the data type we want it changed into. So double here. What that does is first turns the value that we're putting here, not the actual variable here, but the actual value, so 10 now becomes a double, so it's 10.0 if you like. And then when we do the division, because this is a double, it allows us to store the decimal point. So we save that, and we compile that, and run it. You can see that we get the decimal point that we're after, the same as what calculator gave us. So that's a little thing I wasn't planning on introducing you guys to, but I'm glad we did. It comes up. It's a nice handy thing to know. Double number A. Firstly, this becomes a double, which now allows us to store a decimal point. So the whole total with the decimal point gets stored over into double quotient variable. So that's division with floating point numbers. If we actually had two new floating point numbers and used them instead of number A and number B, we wouldn't have to typecast it because that'd already be a float or a double. So we wouldn't have to worry about that. Now, you can't just convert anything into anything using this typecasting. If you try and do something that Java doesn't like, you'll get a compiler error. Okay, and I'm not going to talk about them too much because the compiler's pretty good at telling you what's gone wrong. So that's division with integers, and that's division with floating point numbers. One stores the decimal point, the other one doesn't. Fairly simple, I hope. So what have we got left? Well, we've got one more, and it's not super obvious, and it is the modulus. And that's done with the percentage sign. What is this? Well, basically, we saw here that number A divided by number B gave us 1, and it missed out the decimal point. What modulus does is basically gives us the remainder of that division. So we do it in exactly the same way. So we'll go int remainder equals number A modulus number B, semicolon. Now, what happens on this line of code? Well, basically it does number A divided by number B, and then gives you the remainder of that division. So if you remember way back in primary school maths, where I come from, it's called primary school. You guys probably call it elementary school. I only know that because I watched The Simpsons, so that's what I'm talking about, if you don't know what I mean. So anyway, we know that 10 divided by 7 goes one time, okay? And then the remainder, so we've got 7, 8, 9, and 10. You guys can't see me counting with my fingers, but you can see that the remainder is going to be 3. And that's what this will give us. If we just print this out, the remainder is... Save that. The remainder is 3. So that's exactly what I was expecting. If you weren't expecting that, maybe brush up on some of your basic maths, but really, hopefully it's not too much trouble for you guys. So that's modulus taken care of. Now we can also do this with floating point numbers, and it will give us the same result, okay, but really, when we're dealing with floating point numbers, we don't worry about it too much because it will give us the decimal point anyway. This is more handy when we're dealing with integers if we're doing something fancy with them, okay? So that's modulus, and with that is all the basic arithmetic operators that we're going to talk about in this video. But wait, there's more. What if you don't have to just do simple things like this? You can do some pretty crazy, complicated equations, if you like. So if we go int crazy equation, now this brings me to another point. When you're writing code, use variable names that are meaningful. Okay, don't, like, we could just go int a and then put something in it, but what does that mean, really, int a? It doesn't mean anything to me, so I'm going to stick with crazy equation. It's not an awesome name, but it'll do for now. This is more important, even more when you're dealing with multiple developers working on the same code, because if you're just using meaningless variable names, they won't know what you're talking about, and really, it's saving a few keystrokes. It's not saving a real lot of time, and it makes code a lot easier to understand. So, rant over, we got crazy equation, and we can do something like this. 4 plus 78 multiplied, actually I won't use 78 because I won't be able to work that out in my head. 4 plus 7 multiplied by 10 minus 11 times by 12, semicolon. Now, what becomes the issue here when we're dealing with more complex equations is the order of operations, or the operator precedence. Now, what I mean is, in, I don't know, about year 8 maths, we talk about this at school. This will not be executed from left to right. The reason is that these arithmetic operators have different precedence, and it's exactly the same as it was at school, or if you're at school, look forward to this. Basically, it goes in the order of operations, parentheses, anything in parentheses gets done first, followed by multiplication and division, and then addition and subtraction. Subtraction. That's the order. So what we'll have here is it won't be 4 plus 7. Okay, so we've got 4 plus 7, so 11 multiplied by 10, okay, and then minus 11. That won't be the case. The multiplication goes first. So what I can do here is actually do this. I'll work this out like we would have in school, okay? So 4 plus, now the 7 multiplication goes first, so we've got 7 times 10 first up, so we've got 70. Minus, now 11 times, it's not minus 11 and then times it by 12, it's 11 times 12, because that goes first. So 11 times 12 is, anyone, 121. No, it's not. 131. Yeah, I'm smart. Look, 11 times 12, 132. I'm way off today. Sorry, I got up really early. I'm a little bit tired. So that's that line of code, and then we go equals. Now it's just addition and subtraction, so it goes left to right, and we can work this out. I'm going to be lazy once again. 4 plus 70 minus 132 will equal negative 58. Okay, so that'll be the result of this equation. It won't be if you go 4 plus 7. Okay, you do that first, so we've got 11, times that by 10, so we've got 110, then minus 11, we've got 99, and then times that by 12, whatever 99 times 12 is. That's not how it's done. I just really wanted to drill that in, because if you are, you don't even have to be rusty. I mean, look at me, I can't even do simple addition and multiplication in my head at the moment. So, it's important. Now, remember, I also said that the things in parentheses always go first. So if you are a little bit confused about the order operations, but you know what you want to have done, just put whatever you need to in parentheses. And then it makes it a bit easier to see, obviously, what's going on. So that's what's actually going to happen. Now, using the parentheses, we can also change the precedence by, if we put something in parentheses like this, this 4 plus 7 will be done first. So it'll be 4 plus 7 times 11, exactly what I was saying earlier. So, order operations is important. Now, what we'll do is just print this out to prove a point. The crazy equation is, we'll save that, and we'll compile that, and we'll run that. You can see negative 58, exactly what we got when we worked it out ourselves. So, that's operator precedence. I just wanted to let you guys know about that, because if you're trying to do things like this and it's not working out how you want, that's probably why it is. So remember, it goes anything in parentheses, then multiplication, division, and then addition and subtraction. Okay, if you can't work out what exactly the order is going to be, just put things in parentheses. It makes it a bit easier to see. So that's operator precedence. So we've looked at all the operators, and we've looked at operator precedence. There's a few more things I want to talk about in this video. The first thing is there's a few little shortcuts we can use in Java to make our life a little bit easier, because as programmers, we're lazy, okay? The first thing I'm going to talk about is increment and decrement operators. So a lot of times when we're running through code, we have a variable and we need to increment it by 1 a lot of times, okay? So what we can normally do, and we'll do this to number A. So we'll go number A. One way of doing this is going number A equals number A plus 1, semicolon. Now what this does is it first takes the value stored currently in number A, so it'll take 10, and then it will add 1 to it, so we've got 11, and then it'll put the value 11 back into the variable number A. That's what happens on this line of code. Now that's fine, but if we're doing this a lot, it can be a bit tedious to write all the time. So this is the shortcut, and that is the increment operator, number A, and it's done with 2 plus signs, semicolon, just like that. These 2 lines of code are exactly the same. Okay? They both increment A by 1. Now, similarly to the increment operator, there's a decrement. This is inc. This is dec. And dec is done in a similar way. If we wanted to do number A equals number A minus 1, we can do it with number A minus minus semicolon, okay? So these 2 lines are equivalent as well, if you like. So one adds 1 to, this one adds 1 to number A, this one takes 1 away. So that's increment and decrement operators. There's also a few, before we get on to the other few, there's also a variation on these, and basically this one is called post-increment, and the other one is called pre-increment, and that's done with plus plus number A semicolon, okay? Now, these, I really don't use this too often, but it can be handy at times. And the thing that happens is it's when this actually gets incremented. And what I'll do, just to start with, we'll comment these out, and we'll have a new variable, int increment equals number A plus plus. And then we'll print this out. Control C, Control V. Now, remember, I commented these out, so when we get to this line of code, number A will be equal to 10. Okay? And then we're incrementing it. Okay, that's what we're doing. So we'll just run this so we can see what's going to happen. Increment is 10. Now, we've incremented number A here, but it's still put 10 in here. That's what I'm talking about, pre-increment and post-increment. What this does is it gives the current value of number A and assigns it to the value increment, and then once that is done, it increments the variable number A. That's post-increment. It's done after, okay? If we change this to pre-increment, we save, and we compile, and we run it. Increment is 11, okay? So in this case, it's incremented first, and then the new value of number A is put into the variable increment. So that's pre and post increment. And similarly to increment, there's also pre and post decrement, and that is with number A, minus minus number A, semicolon. Okay, so that's pre and post increment. Yeah, like I said, I don't really deal with this one too often, but it does come up occasionally, so it's important to know that it exists. It might save you some headaches. So, that's increment and decrement taken care of. There are 4 more that I want to deal with. A lot of times we want to add a variable to another variable. Now, what I mean by that is we might want to go number A equals number A plus number B. Okay, this comes up a lot. We want to take the current value of number A, add the value of number B to it, and then put this total back into the variable number A. Now that's fine, but once again, coders are lazy, so we've got a shortcut to make life easier for us. And that is number A plus equals number B. Okay, now these lines are equivalent. What it's doing is taking number A, adding number B to it, and then storing the total back into number A. So it saves us a little bit of code, and it does come in very, very handy. So that's the plus equals operator. Similarly to that, there's also, if we do number A equals number A minus number B, there's an equivalent of that, which is number A minus equals number B. Okay? So again, there's also the same thing for multiplication and division. So if we have number A equals number A multiplied by number B, we've also got the shortcut number A multiplied equals number B. And we've also got it for division, number A equals number A divided by number B. We've got number A divided by equals number B. Okay, so there are 4 different shortcuts we can use. Okay, so each of these are equivalent. They do the same thing. So if you are one of these lazy programmers like we all are, a bit of a shortcut which can come in very handy very, very often. So, before we go, now this reminds me, this divided by equals thing, I don't know why. It's very important that we do not divide by 0 in Java. Okay, so if we do this, change number B to 0, so when we get to here it'll be 10 divided by 0. You can't do this in real life, and you definitely cannot do this in Java. It compiles fine. Note how it compiled fine. Because when it compiles, it doesn't actually do this addition, okay? This division. It's done at runtime, so it hasn't checked to see what's going on. So if we try and run this, however, exception in thread main, java.lang.arithmetic exception. Okay, we're going to get into exceptions a bit later as well, but you can see the error fairly obviously, divide by 0 at arithmetic.main, so we're in the main method of the arithmetic program, on line in arithmetic.java line 27. So we can see on line 27, we tried to divide by 0 and it didn't like it. Okay, so remember that, if you get these exceptions, that's what it is. Do not divide by 0, you can't do it. So, what have we talked about in this video? We've talked about addition, subtraction, multiplication, division, modulus, which is just basically the remainder of a division. Then we've talked about the increment and decrement operators. We talked about pre-increment and post-increment, and the same with decrement. Then we've talked about these 4 shortcuts, which make life a little bit easier for us. So with that, that's all I want to talk about in this video. If you've got any questions, comments, complaints, whatever, just drop a line in the forums, or if it's something really important, send me an email. But yeah, that's going to wrap up this video, so thanks a lot.